How do we add or subtract radicals? This is the question we will answer for today's video tutorial. But before I start, make sure to hit the subscribe button and the notification bell to be updated with my latest content. Likewise, visit my Facebook page, Math Sherwin Math Tutorial, and like and follow this for more updated lessons. So are we ready? Let's begin this math lesson. Now, hello dear math buddies, my name is Sir Sherwin and I will be your math instructor. For today's video tutorial, I will teach you on how to add or subtract radicals. But before I start, let us first differentiate similar radicals from dissimilar radicals. When we are asked to define what is similar radicals, similar radicals or like radicals are radicals containing same index and same radicand. And this would be the example of similar radicals. We have cube root of y, 4 cube root of y, and negative 2 cube root of y. They are considered to be similar or like radicals because these radicals contain same index, likewise same radicand. In this certain radicals, our index is 3 and our radicand is y. They are considered as similar or like radicals. This second set of our radicals are also known as similar or like radicals for the reason that square root of 2, 10 square root of 2, and 2 square root of 2 all over 3 have the same index, which is 2, and their radicand, which is 2 as well. So we have same index and same radicand. So therefore, this is considered as like or similar radicals. On the other hand, when we define the similar radicals, we are referring to radicals containing different index or different radicands. And these are the examples of the similar radicals. We have 2 cube root of y, 3 square root of y, and negative 5 fourth root of y. Here, we notice that our radicand is the same, and that is y, but these radicals differs with their indices. Here, our first index is 3, our second index is 2, and our third index is 4. If our radicals contains different index, then these radicals are considered to be dissimilar radicals. For our second example, containing radicals negative square root of x, 7 square root of xy, and negative square root of y, we noticed in these radicals we have same index, and that would be 2. But in this case, our radicals contains different radicand. In our first radical, our radicand here is x. Our second radicand, in our second radical expression is xy, and our third radicand is y. This means we have different radicands, and this is one characteristic of a dissimilar radicals or unlike radicals. Let us try to describe this set of radicals containing square root of 72, square root of 18, and square root of 8. At first glance, you can conclude that our radicals are dissimilar radicals for the reason that they have different radicand. Probably that idea would be considered correct. But before we conclude if it is dissimilar or unlike radicals, let us also be reminded that it is very important for us to simplify it first. In our previous video, I discussed already on how to simplify radicals, and this would be used in simplifying this expression. So let us first simplify square root of 72. So square root of 72 is a number containing factors where one is a perfect square and the other is a non-perfect square. So we will choose factors where one is a perfect square and the other is a non-perfect square. So 72 has factors 36 times 2. And using the product rule, we can say that square root of 36 times square root of 2 is equal to square root of 72. So 36 is a perfect square, so we can write this one in exponential form, and that would be 6 squared, while we will copy square root of 2. We can cancel out our radical symbol since the index and the exponent of the radicand is the same, leaving 6 square root of 2. This means square root of 72 can be written as 6 square root of 2. So we have 6 square root of 2. For square root of 18, we can determine its factor where one is a perfect square and the other is a non-perfect square. And that would be 9 times 2. So again, applying the product rule, we can write this one as square root of 9 times square root of 2. So square root of 9 can be written in exponential form, and that would be 3 squared. And again, we will copy square root of 2. So we can eliminate our radical symbol since the index and the exponent of the radicand is the same. So we will have 3 square root of 2. So square root of 18 can be written as 3 square root of 2. And for square root of 8, we will think also for a factor of this number where one is a perfect square and the other is a non-perfect square, and these factors would be 4 times 2. So applying the product rule, we can have square root of 4 times square root of 2. Since 4 is a perfect square, we can write this one in exponential form, and that would be 2 squared. And again, copy square root of 2. So we can eliminate our radical symbol since our index and exponent of the radicand is the same. So we will have 2 square root of 2. So this would be the simplified form of square root of 8. So we can write square root of 8 as 2 square root of 2. By this time, our radicals are written in its simplest form. And here, we noticed that they have the same index, which is 2, and the radicand, which is also 2. Therefore, we can consider that this set of radicals are similar radicals or like radicals. Why is it very important for us to be aware if our radicals are similar or dissimilar radicals? It is because in adding or subtracting radicals, we can only add or subtract if and only if our radicals are similar radicals. Again, we can only add or subtract radicals if they are similar radicals. And in adding our radicals, bear in our mind this significant idea. We can only add or subtract the coefficients of our similar radicals. And second, we will just simply affix our radicals. So that's 2 basic steps in adding or subtracting radicals. This time, let's try to proceed with our first example as we add or subtract our radicals. And our given is 8 square root of 3 minus 4 square root of 3. From this given example, our radicals contains same index and same radicand. Therefore, our radicals are considered to be similar radicals. And again, in adding or subtracting these radicals, we will simply add or subtract our coefficients. And from this certain example, the coefficients are 8 and 4. And the operation involved between them is subtraction. This means our solution would be 8 minus 4, then affix our radicals, which is square root of 3. So, subtracting 8 and 4, that would be 4, and copy the radical square root of 3. This means the difference of our first example is 4 square root of 3. Let's have the second example, and this expression contains 4 square root of a plus 7 square root of a minus 3 square root of a. Here, our radicand is a and our index is 2, so it follows that our radicals are considered similar radicals. So again, we will simply add or subtract the coefficients, and we are referring to 4, 7, and negative 3. So we will simply add 4 and 7 and subtract 3 and affix our radical, which is 8. So to simplify, that is 4 plus 7, that is 11, minus 3, we have 8, and affix our radical, which is 8. So therefore, the simplified form is 8 square root of 8. So this is how to add or subtract our radicals. Let's have the third one. We have 5 fifth root of 5 minus 10 fifth root of 5 plus 15 fifth root of 5. Here, our radicals contains same index, and that is 5, and our radicand is also the same, and that is 5. So again, bear in our mind that we will simply add or subtract our numerical coefficients. We are referring to 5, negative 10, and 15. So adding this or simplifying this, that is 5 minus 10 plus 15, and affix fifth root of 5. So 5 minus 10, that is negative 5, plus 15, we have positive 10, fifth root of 5. So this would be our answer. Let's have the fourth one. We have 7 square root of 27 minus 2 square root of 12 minus 3 square root of 75. At first glance, you can notice that our radicands are different, because we have radicands 27, 12, and 75. And probably you are concluding that these radicals are dissimilar radicals, and we cannot add or subtract this one. But remember, make sure to simplify first your radical. Since our first expression is 7 square root of 27, and our radicand is 27, so we will think of a possible factor of 27 where 1 is a perfect square for the reason that our index here is 2, and non-perfect square. So probably 27 have factors 9 times 3, while 12 has factors 4 times 3. And same concept will be applied with 75. So we will think of possible factors of 75 where one is a perfect square and the other is a non-perfect square. And 75 has factors 25 times 3. So applying the product rule, we can simplify this as 7 square root of 3 squared times square root of 3, that is for 9 times 3. For 4 times 3, we have 2 times square root of 2 squared times square root of 3. And for 25 times 3, we have 5 squared times square root of 3. Then, we can simplify. Since our index and exponent of the radicand is the same, so we can cancel out the radical symbol, leaving 3, and copy the radical square root of 3. Then, we can also eliminate our radical symbol here, since our index and exponent is the same. So we are leaving 2, and copy square root of 3. And for our third expression, we can simplify as well by eliminating radical symbol, since the index and the exponent is the same. And that is 5, and affix the radical, which is square root of 3. So the operation between 7 and 3 is multiplication. So we will simply multiply 7 and 3. So the product is 21, affix square root of 3. Likewise, 2 times 2, that would be 4. Affix the radical, which is square root of 3, and 3 times 5, that is 15, and affix the radical, which is square root of 3. Here, we notice that our radicals are now similar radicals, since we have the same radicand, which is 3, and index, which is 2. Therefore, we can simply add or subtract these radicals, and that is by adding or subtracting their numerical coefficients. So we have the numerical coefficients 21, -4, and -15. So we will have 21 minus 4 minus 15, and affix the radical, which is square root of 3. Therefore, our answer would be 2 square root of 3. So this would be the answer as we simplify this expression. Let's have our fifth example. We have 4 square root of 3 plus 3 square root of 2 minus 5 fourth root of 3. Here, we notice that we have different indices and at the same time different radicands, and our radical cannot be simplified. Therefore, we can conclude that these radicals are dissimilar radicals. Remember, we can only add or subtract radicals if they are similar radicals. In this case, we cannot combine our radicals. So our final answer would be simply copying the given radicals itself, and that is 4 square root of 3 plus 3 square root of 2 minus 5 fourth root of 3, and have this one as your final answer. In my next content, I'll be providing more examples on how to add or subtract radicals. But before I end, make sure you hit the subscribe button and the notification bell to be updated with my latest content. And I will be more glad if you will like this video, leave a comment, and share with friends. There you have it. Hope you learned something new today. God bless us all.